We have our keypad over here, and we have Arduino Uno board and a few jump wires. So let's connect them to our keypad. So I have connected the first jump wire to the keypad. Do the same for rest 7 of the jump wires. Alright, so now I'm done with connecting all the 8 jump wires. So we have our Arduino board over here. Take the previously connected keypad with the jump wires. Connect the rightmost jump wire to the pin number 2 and the adjacent one to pin number 3 and the next adjacent one to pin number 4 and so on. Keep doing it repeatedly until you run out of all the jump wires. So our last jump wire connects to the pin number 9. So we are done connecting all the 8 jump wires to our Arduino board pins. So quickly moving on to the programming part. We are using the Arduino's official IDE. You can download the Arduino's official IDE from the Arduino's website. So to execute the keypad program, we need an external library called keypad.h. So the links to this library is given below in the description. Please check out and download the library. Once you download the library, you can see a zip file like this. Go back to your Arduino IDE and choose Sketch, Include Library and add zip libraries. And in this, locate your zip library that you have downloaded. So this is the library I have downloaded a few minutes ago. I'll just open this. So currently the library already exists in my system. So in case it doesn't exist in your system already, you should see a message saying that library keypad library has been added to your libraries. So once it's installed in your Arduino IDE, go to Sketch again, include library, and you can see an option called keypad over here. So this means that we have successfully installed the keypad library onto our computer. So we have our code for using our keypad, and this code, the link to this code can be found in the description below. Just go ahead and download it, and then you can load the code into your Arduino IDE. The first thing that we see is hash include keypad.h, which is basically including the libraries of keypad.h that we installed previously. Then we declare a constant by type rows equal to 4, which means that there are 4 rows in our keypad. Const byte calls equal to 4, which is a constant byte type, and the value is 4, which basically means that we have 4 columns in our keypad. Then we have a character array of 2 dimensions called keys. In this, we declare all the keys that we have. The first key is 1, the second key is 2, the third is 3, the fourth is A, then the next is 4, 5, 6, and so on. So the next one is row pins array. Here we declare and initialize the row pins, which is 9, 8, 7, and 6. Then we have column pins over here, which has the size 4. Here the pin numbers are 5, 4, 3, and 2. Then we have something called keypad, which is of the class keypad from the library keypad.h. So the constructor takes 4 parameters. The first parameter is the key map that we create using the keys character two-dimensional array. And then the second parameter is the pins, the row pins. The third parameter is the column pins, and the fourth is the number of rows, and finally the number of columns. So we have our setup function over here. As you know, setup function only runs uh, once in the program at the beginning. So serial.begin 9600, which is used for the serial monitor. And then we have loop function. Now everything inside the loop function is repeated again and again, as the name loop itself indicates that it keeps on looping. So in the loop function, we have declared a character key, and we're taking the value for the character key from keypad.getKey. GetKey is a function of keypad class from keypad.h library. So it basically gets the key that has been pressed from the keypad. So if key not equal to no key, which means the keypad in keypad some key is pressed, because if key is not equal to no key, it means that there is some key that has been pressed. So if there is some key that has been pressed, serial.println key, which is a character key, will be printed. So if you press 2 on the keypad, the serial monitor will display 2. Simple as that. So this is the initialization part, declaration and initialization part. Then we have setup, which is pretty simple, and we just write serial.begin 9600 as usual. And in the loop part, we just get the character key, and if that key is not no key, we display the key onto the serial monitor. Now let's connect the USB cable to our CPU and connect the other end to the Arduino board. So now we have connected the Arduino board to our computer. So compile the sketch and start uploading the sketch onto the Arduino board. So now it's uploading. Yes, it's done uploading. Now go on to the serial monitor and try pressing any key and see if the output is shown on the serial monitor. So I'm pressing 1 on the keypad, now 4, and now 7. So as you can see, it's showing all the results that I'm pressing on the keypad. So now we are going to input a password, and if the password matches with our password saved in the program, the light connected to the Arduino will glow. So let's see how we can implement this. So first we have our keypad.h library installed. So next we have the LED pin 13. Now the rows are 4 and the columns are 4. These are the keys that we have declared. This is the column pins and the row pins that we have declared before as well. So this is a void setup which will be run only once, and we asked enter your password in the beginning. So here we are declaring our password ABC. So the temporary variable is the where we are going to store the temporary password entered by the user. We have correct count initialized to 0 and total count initialized to 0 as well. So the loop function basically repeats again and again. So the key we are declaring as character type and inputting the key from the keypad. So if key is not equal to no key, which means the user has entered one of the key, we increment the total count by 1, which means that if the user presses any key, the total count will be incremented by 1. So if the password of the correct count is equal to key, we increment the correct count by 1. So if the correct count is 3, which means that the user has entered the correct password, we print the message saying it's a correct password, and we glow the LED light with digital write LED pin high, and we give a delay of 1 second, and then we reinitialize the total count and the correct count. So if total count is equal to 3 and the correct count is less than 3, which means that the user has entered a wrong password, we are going to print the message saying it's wrong password, and then reinitialize the correct count is equal to 0 and the total count equal to 0. So outside this if condition, we are giving a delay of 500 milliseconds, and digital count LED low. So thank you for watching, guys. Please like, share and subscribe. Thank you.